In this video, we're going to go over some of the rules that you'll probably already have become acquainted with from pre-calculus or Algebra 2, or have been introduced to by your calculus teacher. In my first video on how to find limits at infinity, I go over the concept behind it. I still want you to understand things that way, but we're going to use that concept now to explain why these rules that you might have been asked to memorize work the way that they do. Again, I'm not a fan of memorizing these rules. I'm a fan of understanding them and using the concept I went over in video 1 of this lesson. Okay, so it says given f of x and g of x are polynomials, then the following rules are true. And let's explain why they are. So let's take a look here. We've got the limit as x goes to either positive or negative infinity. Doesn't matter which one you go to, and technically we can't go to both positive and negative infinity. I'm saying you either go far to the right or far to the left. So it doesn't matter the sign. And you've got f over g equals to 0 when the degree of f is less than the degree of g. So here you've got an example. You've got x squared minus 3x plus 4, 9x to the 5th minus 10x squared plus 7. Remember from my last video on this that this is essentially approximately the limit as x goes to infinity of x squared over 9x to the 5th. Because as x goes really, really large, it's just the leading coefficients that matter. You're taking the ratio of those. I'm sorry, the leading terms. And so since the degree of the numerator, it's got a lower power than the degree of the denominator, which has a higher power, this is going to go to 0, which makes sense. This would simplify down to 1 over 9 x to the 3rd. And if I take a limit as x goes to infinity of that, we get 1 over huge, which is 0. That's why that rule works. On to the second rule. Doesn't matter if we go to positive or negative infinity, but if we've got a ratio of f over g, the ratio of the leading coefficients is our answer to an infinite limit, if and only if the degrees of the top and bottom are equal. In other words, we look at this and we say, the degree of the leading coefficient is x, of the leading term is 2. The degree of the denominator's leading term is also 2. But using our logic from before, we saw that the limit is as x goes to negative infinity of 10x squared all over 12x squared. And if you're looking at that, you're like, wait a second. That essentially equals out to the limit as x goes to negative infinity of 10/12, which is the ratio of the leading coefficient. So anytime you have the same exact power of the highest powers, numerator and denominator, and you're going out to infinity, you take the ratio of the leading term. So right away, 10/12, which simplifies, of course, to 5 over 6. Done. Last but not least, if you've got the limit as we go to infinity or negative infinity, and the leading terms have a degree higher in the numerator and lower in the denominator, then the limit will not exist. We'll go to one of the infinities. So this, just case in point, would be the limit as x goes to infinity of x squared over x. Remember, all the lower powers do not matter in numerator and denominator when we're going to infinity. That's the same as the limit as x goes to infinity of x. So now if we take a look at that, that's just plugging in infinity. Well, that's going to go to positive infinity. So the limit does not exist. So again, to review, when you've got two polynomials stacked one on top of the other, you look to the highest powers in top and bottom. If you have a larger degree in the bottom, smaller in the numerator, the top, we're going to 0. If we have the same degrees, it's the ratio of the leading coefficients. If we have a higher degree in the top than on the bottom, we will go to either positive or negative infinity. No matter what, though, the limit won't exist. That's it. Those are the rules that you likely will have been asked to memorize, but it comes from the conceptual understanding of what I went over in video 1 of this lesson. Please, please, please understand that concept so you don't get caught memorizing stuff and mismemorizing it. All right, I will see you soon. I can't wait. You're probably like, I could wait a little bit. That's cool. I'm ready when you are. See you next time.